Hello everyone. In this video we are going to solve the problem number 1.47 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A solid body starts rotating about a stationary axis with an angular acceleration beta is equal to at, where a is given as 2 into 10 to the power minus 2 radian per second cube. So let us say this is a solid body which is rotating about an axis passing through this particular point, and the angular acceleration of any body about this particular point is given as beta is equal to at, and a is given as 2 into 10 to the power minus 2 radian per second cube. Okay, and it is asking how soon after the beginning of rotation will the total acceleration vector of an arbitrary point of the body form an angle alpha is equal to 60 degree with its velocity vector. Okay, so let us say this is the point a, arbitrary point a, and the distance between this particular point and this particular point, let us say, is r. Now if we talk about the acceleration of this particular point, then we are having two component of acceleration. One is in the tangential direction or perpendicular to this radius vector, let us denote it at at, and another will be the normal acceleration towards the axis of rotation. So this is, let us say, an. Okay, now if we talk about the velocity vector, so the velocity vector will always be in the tangential direction. Let us say this is v, which is also perpendicular to this particular radius vector. Now in the problem it is asking to find the time instant at which the total acceleration, let us say this is total acceleration, is making an angle of 60 degree with the velocity vector. If we carefully look at here, this is also the angle between the tangential acceleration and the total acceleration. Okay, so we can say, let us say this is the tangential acceleration, this is the normal acceleration, and this is the total acceleration. And in the problem it is asking to find the time instant at which the velocity vector is making an angle of 60 degree with the total acceleration vector. We can also say that this is the angle between the tangential acceleration and the total acceleration vector, because tangential acceleration and the velocity vector both are in the same direction, and this is angle 60 degrees. So from here we can write tan 60 degree is equal to an divided by at. Okay, so at a particular time instant we can write an is equal to v square by r, where r is the distance between these two particular points. Okay, and we can write at is equal to r into beta, where beta is the angular acceleration. Now beta is given as a into t, so we can write at is equal to r into a into t, and if we write an is equal to v square by r, so for that we have to find the velocity. We can write at is equal to dv upon dt is equal to r into a into t. If we take dt to this particular side, then we can write dv is equal to rat into dt. Let us integrate both the sides from v is equal to 0 to v and t is equal to 0 to t. So in the left side we will get v is equal to ra is constant and the integration of t is t square by 2 from t is equal to 0 to t. So from here we will get v is equal to ra t to the power 4 t square by 2. So this is the expression of velocity we got. Now let us find out the value of normal acceleration. For that we can write ra t square whole square by 4 whole divided by r. So we can get r square a square t to the power 4 whole divided by 4r. r will get cancelled and we will get ra square t to the power 4 whole divided by 4. Let us substitute the value of normal acceleration and the tangential acceleration here. So we can write tan 60 degree is equal to an is ra square t to the power 4 by 4 ra square t to the power 4 whole divided by 4 whole divided by 80 is RAT. So here R will get cancelled, AA will get cancelled, and T from here we can write T to T cube. Okay, so we got A times T cube whole divided by 4. So if we find the value of time instant, we can get T is equal to 4 by A times tan of 60 degree to the power 1 by 3. So this is the time instant we got at which the tangential acceleration is making an angle of 60 degree with the resultant acceleration vector, or we can also say that this is the angle between the velocity vector and the total acceleration vector. I hope the entire procedure is clear. Thank you.